Hey, 7th graders. Today's assignment is going to be 1.3 populations, and it's going to be somewhat similar to what you guys are doing tomorrow in class with the little hands-on activity. I guess some of you guys will be doing it from home. But your learning targets are any rate. I can model how to change the size of a population, and I can describe how births and deaths influence the size of a population. So to get started today, you guys have a little bit to add to your OneNote. You guys should have started a new section with 2 new pages yesterday and added some things to it. Today we're going to add concepts 3 and 4. Notice how we skip key concept 2. And then you guys are going to add stability to your vocab. Once you guys have finished that, you guys can move on to activity 2, which, you know, if you're in class, it's going to be a little hands-on activity. But for those of you guys who are doing this assignment at home, I'm going to make it as hands-on as possible for you guys. So basically what you guys are going to be using are little tokens to simulate a population. And we're going to look at 3 different population models. One in which the population number is staying about the same size, it's stable. And another one where you guys have a population size increasing over time. And then finally, where you have your population size decreasing over time. Okay, so what you guys will see is on each page, you guys will have a little circle that will be your guys' little population area. And in that circle, you'll see 14 yellow tokens. Okay, you guys will choose how many you guys are going to add each year. So you're going to either add some to show births or you're going to take some away to show deaths. But your overall goal for each of these are to complete each of these 3 missions. And then you guys will graph your results, and hopefully you guys, when you graph your results, can show that you've completed these missions. So let's take a look at what this looks like. Here's your little population circle. Notice there's already 14 tokens that you guys can click and move in there. Okay, and out here you guys have other tokens that you guys can use to help you simulate births and deaths. So your first mission in this is to make the population stay the same over time. So you guys would have a stable population. Okay, so again, you guys are going to get to choose how many births and deaths occur each year between 1, 2, and 3 individuals. But overall, your guys' population should be about the same. So we're starting off with a population of 14. That doesn't mean that every year you guys end with a population of 14. It's going to fluctuate like a normal population would, but when we look at the end of a 6-year period time, it should still be pretty close to 14. Not necessarily exactly, but pretty close. So I've already kind of done some examples for you guys, and I'll show you how to graph them. So in the first year, I got to choose how many births and how many deaths I wanted. And again, you guys can choose between 1, 2, or 3. So I decided that 2 individuals would be born into my population, but 3 would die. So I would go up to my little model here and I'd say, all right, 2 are being born. So I'm going to add 2 tokens. Okay, and 1's going to die. So I'm going to take 1 token out. If I count that up, I should see that I have, 2 births, so 2 plus 14 is 16, minus 3 deaths, 16 minus 13 is 13 individuals, and I should count 13 individuals there. Okay, then I'm going to do the same thing. I'm going to go and say, all right, my next year, I decided that there's going to be 3 born, and 1 died, so I'd go back up to my model, I'd add 3, subtract 1, and then do my math to say, all right, 15 is the end is my population for the end of that year. Then I can go up to my draw tool here and I can graph those, okay? And you guys can graph them as you go, or you can graph them when you're all done. That's totally your option. But notice how my population started at 14. There's that little dot right here. And after my first year is this first grid line, I ended up with 13. Notice how it's not exactly the same as 14, but it's pretty darn close. And then after year 2, I went up to 15. Again, that's still pretty close to 14, but not exact. And then I'm going to play a little game of connect the dots as best as you guys can with that draw tool. Okay, so I'm going to go ahead. You guys are going to add data for years 3, 4, 5, and 6. You're going to add up your totals, how many total died and how many total were born in your guys' population over that 6-year period. And then you guys are going to graph and connect all those little plot points on your graph. All right, moving on to your second mission. Notice you guys have a new kind of reset here where you have 14 in your population whole and then extras over here. And your mission for this one is to make your population increase over size. So if you were starting with 14, okay, you're going to want your population at the end of this 6 years to be higher than 14. Probably more than 1 or 2 higher than 14 to really be significant. Okay, so choose how many births and how many deaths each year that need to happen for you to accomplish that goal. Fill in your data, plot your guys's numbers on that graph, and then go ahead and graph that out and make me a line graph there. Your final mission is to make your population size decrease over time. So again, choose how many births and deaths between 1, 2, and 3 for each year. Do your totals, graph them, and move on to the last section of this. It's just a little video that talks about stability. It doesn't really have to focus on population, so you guys will see that it's just another example to show you guys how other things can be stable, increase, or decrease, and what that might look like in a system. It looks a little bit like this. Okay, all right, watch that, and then you guys can go ahead and do your lesson wrap up. Do you have any questions? Use the draw tool to circle yes or no. If you have questions, type them below, but remember, if there's something that's preventing you from completing this lesson, you guys probably need to send me a message in Teams so I can help you guys right away so you guys get everything you need to out of this assignment. And then 4, 3, 2, 1, how do you think you did? You guys are done. Go ahead and turn it in, and I will talk to you soon.